The first thing that we are going to try do is to find the expression for dy dx. So to do that, we need dx dt. So differentiating this with respect to t gives us a 6t. And we need dy dt. dy dt is equal to 6. And now we can come out with our expression for dy dx, which is going to be dy dt divided by dx dt. So the expression is 1 over t. And now we can come out with the equation of the normal at the point 14, 11. Because at this point, the x coordinate is equal to 14, the y coordinate is equal to 11. What we are now lacking is just the gradient of the tangent at this point, because that will help us to deduce the gradient of the normal. So to find the gradient of the tangent, we need the value of t so that we can evaluate dy dx. So to evaluate the value of t, we can either equate 3t squared plus 2 to 14, or we can equate 6t minus 1 to 11. And of course, I'm going to make use of 6t minus 1. So 6t minus 1 is equal to 11. It is like not way simpler, but it is just going to be simpler so that I don't need to work with a t squared. So from here, we are going to work out the value for t. T is equal to 2. So now we can find out what is dy dx, and that is 1 over t, which is 2. And we can now then form the equation of the normal, which is line n. So I will take y minus the y coordinate, which is 11, is equal to the gradient of the normal. Gradient of the tangent is half, so the gradient of the normal is minus 2. Then x minus the x coordinate, which is 14. So we have a minus 2x. If I were to bring it over to the left hand side, we will have a 2x plus y minus 11. If I were to bring it over to the right hand side, this is equal to 39. And this is of the same form as the one that the question has given us. And comparing this to what the question has given us, we can see that this is a. So a is 2. The coefficient of y is b, so b is equal to 1, and this is c, so c is equal to 39. Let's first try to visualize the area that is enclosed by curve C, the line N, and the x-axis. So for the line N, it is going to be passing through the point 14, 11. So I press into my calculator, letting t be equal to 2. I'll get this point here. And when I let y be equal to 0, x is 39 over 2. 39 over 2 is somewhere here. So if I were to sketch that line will look something like this. This is going to represent for us the line N. And you may notice that this line N is not exactly visually like perpendicular to the tangent at this point. And that is because the vertical and the horizontal scales, they are different. Okay, but it is definitely a normal to the curve at the point 14, 11. So this is the area that we are looking at, this area. And this has a coordinate of 14, 11. So we're going to break up this area into two parts. First is going to be this region here, and then it's going to be this region. For this region, it's not too bad because we are looking at a right-angled triangle where here is this point here is 39 over 2, 0. So this length here is going to be 39 over 2 minus the x coordinate of this point, which is 14. And the height is just simply going to be 11. And now it is going to be this part here. So for this part here, we are going to make use of integration. We are going to be integrating from the x coordinate of this point to the x coordinate of this point. So the x coordinate of this point is 14. We need to know what is the x coordinate of this point. And when you press this into your calculator, letting t minimum be 1 over 6, you realize that the curve starts from here and you will just continue. So you can do a quick test. When you let t be equal to 1 over 6 on your calculator, the points will actually be cutting here. And the coordinate that the calculator will be giving you will be 25 over 12. 0. So we know that this point here, which is in contact with the x-axis, is when t is equal to 1 over 6 and the coordinate is 25 over 12. You can also substitute 1 over 6 into here, and you realize that y is equal to 0. So substituting 1 over 6 into here, you should get 25 over 12. So we are going to be integrating from the x coordinate of this point, which is 25 over 12, all the way until the x coordinate of this point, which is 14. And we're going to be integrating the curve, so y dx, plus the area of this triangle. As what we have just discussed, it is going to be half times base, which is 39 over 2 minus 14, times height, which is 11. So now let's do a bit of substitution. This is x coordinate when t is equal to 1 over 6. So I'm going to replace this by t, which is 1 over 6. 14, this is when t is equal to 2. So 2, y is this expression here. So we have a 6t minus 1. And dx, I'm going to be replacing it. So for this dx here, I'm going to replace it by, because dx dt, we have found it to be equal to 6t. So we are going to replace dx by 6t dt. So this, I'm going to replace it by 6t dt. Then plus this is equal to 121 over 4. And if I were to press this into the calculator, this entire integral here into the calculator, I will be getting a 3025 over 36. So this plus 121 over 4 gives us the area of the enclosed region as 2057 over 18. In 3 part A, x is going to be scaled by a factor of 2 and y is going to be scaled by a factor of 3 for this curve C to form the curve D. And I personally find that it is a bit difficult to visualize for when it comes to the area of the transformed graph. I know this is a 1-mark question and we can basically just take this, multiply by 2 and then multiply this by 3 and you will get the answer immediately. But maybe let's just go for a quick verification in terms of the solution that I'm going to be generating. Preferably in the exam, if you guys are able to visualize it, you just take this, multiply by 2 and then multiply by 3, you should be able to get the answer. But okay, if I were to go through the whole process for the curve D, x is going to be scaled by 2, which means that I'm going to be replacing x by half x. So replacing x by half x gets me this, so 3t squared plus 2. As for the y, it is going to be scaled by a factor of 3. So I'm going to be replacing y by 1 over 3y. So this is equal to 6t minus 1. As for the new area that we are looking at, it is going to be integrating from, previously we were integrating it from 25 over 12. So that is this point here. And since it's going to be scaled by 2, so it is going to be 25 over 12 times 2. The same goes for 14. It will be 14 times 2. The new y, sorry, let's just go for the same y first. Then after that, dx. Then plus, it is going to be half of, for the horizontal distance, it is going to be 39 over 2 times 2 minus 14 times 2, because all the x coordinates are supposed to be scaled by 2 times. As for the y coordinate, it's going to be 11, scaling by 3 times, so times 3. Now if we were to replace this by t, the t is going to remain the same. So for this, it is still going to be at 1 over 6. And for this, it is still going to be at 2. As for y is going to be replaced by 3 times of 6t minus 1. So this y here will now be 3 of 6t minus 1. As for dx dt, so if I were to differentiate this with respect to t, we will have a half dx dt equal to 6t. So dx dt is 2 times of 6t. So it is going to be 2 times of 6t dt plus this, I'm going to factorize out 2 and I'll factorize out 3. It is going to be half of 39 over 2 minus 14 times 11. Since we have factorized out 2 and factorized out 3, we will get this, which is exactly the same as the area of triangle from the previous part. So it is 2 times 3, and 2 and 3 are here, which we can also factorize out, which means that we will actually be getting a integration from 1 over 6 to 2 of 6t minus 1, 6t dt plus half of 39 over 2 minus 14 times 11. And this, if I were to factorize out 2, 3, 2, 3, I will have a 2, 3. And this is exactly the same as what we have calculated previously. That is why the area is going to be equal to 2057 over 18 multiplied by 2 and then multiply by 3. And this will give us our final answer as 2057 over 3. In the previous part, we have obtained the parametric equation of D. So we are going to make use of this and we are going to form the Cartesian equation for D. I'm going to make use of y first. So 1 over 3y, this is equal to 6t minus 1. And if I were to make t the subject, it is going to be equal to 1 over 18y plus 1 over 6. And I'm going to substitute this into the t in the equation that involves x. So substituting this back into here, we will have half x is equal to 3 times of t, which is 1 over 18y plus 1 over 6 square, then plus 2. This is going to be the Cartesian equation of the curve D. So let's do a bit of simplification. 2, if I were to multiply it over, I'm going to get a 6. And this is equal to y plus 3 over 18 square plus 4. And if I were to factorize out 18, I'll have 6 over 18 square. Then y plus 3 square plus 4. So the Cartesian equation in the simplified form will be 1 over 54 y plus 3 square plus 4.